Hey guys, so here is some benchmark questions that are focusing on factoring or polynomials, which is still a pretty broad topic here. But so we have taken two benchmarks. We took one in the fall and we took one in the spring. There was a third one that the county had, but just for time wise, they said, teachers, you're welcome to use it. You're welcome to give it. So I could have given it to us on the TE21 platform, and I was like, we just don't have time. So it's still a great resource because this third benchmark was a cumulative one. So it has everything. So I went through and I pulled on here the questions from that benchmark that would do with factoring and polynomials. So you're welcome to watch this video and check out these problems. Or you can skip it and just get on to the practicing factoring and polynomial concepts. So let's look at this first one at the top. You've got a table, shows the work of a student who rewrites the expression x to the 6 minus 4x y to the 6. And you've got your steps there. Which expression is missing in step 1 that allows the student to complete the factorization shown in step 2? So because these are even exponents, and I can see that the 4 is a perfect square, and we're subtracting. So this is focusing on the difference of squares formula. So that formula is for factoring, say, a squared minus b squared would factor into a plus b, a minus b. So what would be the square root of x to the 6? Because if I want to find what was the a value that was squared and bring it on over into my binomials that are multiplying, I need to find what was the square root of x to the 6, and that would be x cubed was being squared. And then my b value, we've got a 4y to the 6. What would be the square root of that? 2y cubed. So those values were being squared. So let's see. X to the 3rd squared, I'm seeing c and d, so I'm going to knock those out. And then we had 2y cubed squared. It is d. Those were the values that were initially being squared. And then they do take it a step further and they finish out the factorization. X cubed minus 2y cubed times x cubed plus 2y cubed. That is a mouthful. That is a lot to say. So there is that problem, focusing on difference of squares. Usually our questions focus on difference of cubes or sum of cubes, but whatever. Second problem, you've got the equation x minus y, x plus y equals x squared minus y squared. That's difference of squares that we were just talking about. Can be used to determine the value of 92 times 88. We talked about a similar problem from a previous benchmark when we went over benchmark questions. This one, they gave you a lot of that extra information that they are trying to tie it into difference of squares. They were surely nice. So if you let, for 92, if you use 90 plus 2, that could work. So let's see. I did 90 plus 2. And then what if I did 90 minus 2 is 88. So that works. You want those to be your x and y. Let me show you. So if I did 90 plus 2 times 90 minus 2, that would give me 92 and 88. Voila. Which equals 90 squared minus 2 squared. See? Right there? Yeah. Yup. All right, moving down. So moving more into polynomials. What are the zeros of the polynomial? Isn't it beautiful? You got x cubed minus 5x squared minus 9x plus 45. Okay, couple things I want to remind you of. Awesome test taking tips. My degree of my polynomial, my highest exponent, my leading term exponent is cubed, 3. The degree of this polynomial is 3. It's odd, and we could go down another path, but I want to say it's 3. So that means I have that many answers. So unfortunately, that doesn't help us here on our answer choices. But if you had any answer choices that only had 2 or maybe 4, you could knock those out. This is a third degree polynomial. There are 3 zeros, 3 solutions, 3 x-intercepts. Done. Cool? Cool. All right. Well, that was fun, but it didn't help. So from here, you could do a couple things. No, you kind of only have one option. Let me choose a color here, orange. So I've got 4 terms. I'm going to use factoring. I'm going to factor this polynomial up, and then I can take the factors and set them equal to 0 and solve. So let's see. Since there's 4 terms, you would want to use the grouping method. So you group the first 2 terms and last 2 terms, and you want to look for a GCF. First group has a GCF of x squared. Next group, GCF of -9, and I chose -9 because I want my 2 binomials left over to match. The x minus 5 and the x minus 5 are the same, and that's how we do grouping. You want them to match or it's not going to factor. Then you rewrite your 2 GCFs that you pulled out, write those as one binomial, and then that x minus 5 we see repeating, you write that once. Now from here, maybe you notice, those difference of squares. X squared minus 9 is equal to x plus 3, x minus 3, and then you have x minus 5. If you didn't notice that, you could take x squared minus 9, set it equal to 0, add 9 to the other side, square root both sides. You took a square root, so plus or minus 3. You could solve it that way. But now that I've got it factored, I would set each of those individually equal to 0 to save space right here. My first binomial, when I solve it, gives me -3. My second binomial, when I solve it, gives me +3. And then my last one gives me +5. So, we could have knocked out A. A had 4 answers, right? We could have knocked that one out. Okay, so we have positive and -3 and a +5. D? Double checking? Yes. Go slow, right? Those signs matter. Now, the next one, let's go to the right. What is the remainder when the polynomial is divided by x plus 2? So still in the realm of polynomials, but now we're talking about dividing. Since your divisor here is x plus 2, you can use synthetic division, and I recommend you use synthetic division. For synthetic division, you take that divisor, set it equal to 0, and you solve. So we're going to get a -2 in our cute little box that we draw ourselves. And then to the side, we are going to list all the coefficients of our dividend. Watch out. I see it here. They're trying to trick us. Every degree of every term has to be represented. So I'm going to have a 2 for that x to the 4th. Let me label so I can show you. Let's start over. Let's do x to the 4th. Then I'm going to have x third, x squared, x, and my constant. You see what I'm saying? So we're going to have -2 in my box. My x to the 4th is a 2. I don't have an x cubed. It's an EOC question. They're trying to trick you. They want to make sure you forget your 0 placeholders. Then we have -4, another 0, and a -16. All right. No sweat. They can't get me. They're not going to trick me. So bring down your first term every time. Multiply it with your box. Add straight down. So synthetic, just think it's cool. It's quick, it's easy. Adding is easier than subtracting. I don't know, whatever you got to tell yourself. Multiply with your box again, add straight down, multiply with your box, add straight down, multiply with your box, and add straight down. Look at that. Apparently our remainder is 0. Just to finish up our review, that bottom row is all the coefficients of your quotient. So it would be 2x to the 3rd. It starts 1 degree smaller, -4x squared, plus 4x, -8, and yes, that last one would be our remainder. But it just wanted our remainder, so we are good. Next one, what is the remainder of the polynomial when it's divided by x squared plus 3? Well, I've got bad news. If your divisor is x squared, you cannot use synthetic division. You got to use long division. So I'm gonna scoot down here because we will have room. Drawing myself a division house. right in my problem. So I did put one long division problem because nobody likes long division. Before it was polynomial, they didn't like long division. Okay, here we go. So you want to look at your very first two terms and you want to ask yourself, what would I have to multiply x squared by to make it x cubed? You would have to multiply it with another x. And you're going to multiply your x on the top by both terms that are your divisors. So x times x squared is that x cubed, haha. And also x times 3 is 3x. Why do they have to be difficult? Womp womp. So let's see if we rewrite it. So we have a big issue, right? So we didn't have a x term. So let me put in 0x plus 3 so we can do this properly. So now when I do x times my 0x, I have 0x squared. And then x times 3, 3x. Woo! Now here's the tricky part. And the reason I don't like long division. So you've got to subtract all the way across all of those. Be super careful. 12 minus 0x squared. That's still 12x squared. 7, that's a 7. 7 minus 3 is 4x. All right, now we're rocking and rolling. Let's go again. I am looking at my x squared and my 12x squared. What would I have to multiply x squared by to make it 12x squared? 12. So 12 times x squared, 12x squared. 12 times 0x, 12 times 0x would be another 0x. And then 12 times 3 would be 36. I didn't bring down my, what should I do that in? Blue? I didn't bring down my 1. Okay, let me scoot this up because long division is long, obviously. Subtract all of that. 12 minus 12 is 0. 4 minus 0 is 4. X1 minus 36 would be minus 35. And I'm out of, let's see, what is the remainder when it's divided? 4x minus 35. Yep. So let me use red. So here's our quotient. We had x plus 12, and then our remainder plus our remainder would be 4x minus 35 over your divisor. You wouldn't have to write the 0x, but there. 4x minus 35. This was a doozy. Okay, so it was D. What a mess. Because we had to do long division. We were missing a term in our divisor. I mean, it's one thing if it's the dividend. Did not like this problem at all. That was a mess. That was rude. All right, next one off to the side. Which expression is equivalent to, and you have a rational expression there. It's not too bad. So rationals can get pretty ugly. We dug into rationals because you have rational standards. This one's not so bad because the numerator there, I've got to write it out because I'm a math teacher. I just got that numerator can be factored. Now, it's not difference of squares. Pull out your GCF first of 3, and then it's x squared minus 9. There's your difference of squares. I told you they like difference of squares lately. And then factor your difference of squares, and that will allow us to do some cancellations. So x plus 3, x minus 3 will help cancel with the denominator x minus 3. Let me change my colors to cancel. And remember, we can only cancel entire factors like in families, in parentheses. So which expression is equivalent? Now, I'm left with 3 times x plus 3. My answer choices, they've got the distributed part, so D. Last one on this page, for a certain polynomial function, f of 6 equals -2, and f of x is evenly divisible by x plus 6, which statements must be true? Select all that apply. So this refers to f of 6 equals -2. That means when I plugged in 6, the remainder was -2. It was not 0, and therefore 6 is not a factor. If it doesn't divide evenly, it's not a factor. Let me give you a baby example. 12. 12 has factors of like 2 and 6 and 3 and 4, right? Because if I divide 12 by any of those numbers, the remainder is going to be 0. If I divide 12 by 2, I get 6, remainder 0. If I divide 12 by 3, I get 4, remainder 0. What if I divide 12 by 5? I get a remainder, right? Because it's not a factor. So same concept here. If you're working with polynomials and you divide them by binomials and stuff, if you have a remainder, it's not a factor. So the second statement says f of x is divisible by x plus 6, and it's evenly divisible. It is a factor, but that means that they plugged in x was -6. So x plus 6 in the parentheses was the factor form. Your x value, your x-intercept, your 0, that term 0, was -6. So let's go to our answer choices. Select all that apply. A says the expressions x minus 6 and x minus 6 and x plus 6 are factors. No, not exactly. Let's see. This one was x minus 6, and it got a remainder of -2, therefore not a factor. The remainder when dividing f of x by x minus 6 is -2. Yes, that's what we just said up here. C, the remainder when dividing it by x plus 6 is -2. No. That's vice versa, what we just said. D, the value x equals -6 is a 0. Yes, that's down here in the green. And then +6 is a 0. No. So +6, that's that first statement that they said. They plugged in a +6, but they got a remainder of a -2 and therefore is not considered a 0, the mathematical term 0 for x-intercept. +6 is not an x-intercept. Okay. A little tricky there because I know a lot of students get confused between the factored form and the x value and when it's a factor and when it's not. So just go through really slow. See how I kind of broke it down before I dove in? Get your brain squared away because these are easy questions if you take your time and dissect. Okay, what do I got as a factor? What do I got as an x value? Which one's divided evenly and therefore are factors? So take that slow because those are pretty popular questions. Second page, getting some easier questions. Look at this. Consider the graph of the polynomial function. What zeros are used to construct the graph? What are your zeros? Your x-intercepts. Looks like maybe a -4, -2, and a 1. -4, -2, and a 1. Is it A? Do not be distracted by that y-axis at all. You are only caring about those x-intercepts. Let me see what these other answers are. -4 and -2 only. -1. I don't even know where they got that. +2 and 4. Oh, is that if you switch your signs? If you are looking for your x-intercepts, these are x-intercepts, you want to take your exact x value. Now, the factored form would be x plus 4, x plus 2, and x minus 1. If you want to switch from the factored form, like if I had my polynomial equation and then I factored it down into the binomials, then when I solve each binomial, set it equal to 0 and solve it, those are the x-intercepts. Cool? And then 2 and 4 only. All right. Second one, consider the graph. If function g of x equals k times f of x maps that y-intercept from 0, -3 to 0, 9, what is the value of k? I had to cut it off so it would fit on the paper. So sorry about that. So what was multiplied in front? They were super cool to tell us that. If you multiply in front, that is going to stretch your polynomial. So we're not just moving it up, or in this case, moving it down. It's going from 0, -3, and it's going to come down here to 0, -9, because we're going to stretch our polynomial a whole bunch. Stretching it means you need a whole number in front, or you can just test this out. What happened? What would you multiply k by? What would you multiply k times y to get that change? -3 times 3, +3, would give you that, would equal your new g of x, or your output value for the g function. So those are your transformations. We've seen those stretches now twice. I don't like stretch questions very much. I'd rather it just be a shift up or down, because that's just adding or subtracting at the end to shift it up or shift it down. A student wants to graph the function. It's so cute. Which characteristics will help the student graph the function correctly? Here we go. All right, we've got x cubed plus 2x squared minus x minus 2. Way back when we first started talking about polynomials, if you switched classes at fall break from Ms. Shanahan, I believe, you kind of missed this stuff, so pay attention. Here we go. It starts with an x cubed. That's odd. Odd polynomials have their arrows go in opposite directions, as opposed to an even degree polynomial where both arrows go the same direction, like our quadratics. There might be some extra humps and bumps in between, but as far as if it's an odd or even, it tells you where your ending arrows are. Opposite directions or same direction. We also have in the front here a nice, beautiful positive. So we've got, since it is positive in front and it is odd, it will be going up from left to right, which means it is increasing. You see that? Increasing from left to right, giving you all kinds of notes here. So let's see what I got. For values, for values of x, for large values of x, they all say that, f of x increases or decreases as x increases. They all say as x increases. So as I put in on my x-axis, as I go bigger, the y is going to increase. Yes? Yes, because we got a positive odd. So we're going up from left to right. And the function has x-intercepts at, let me talk about that other trick. So it is a third degree polynomial. There should be 3 x-intercepts, 1, 2, 3, 1, 2, 3. So this one only has 2. So cross out b. And this one only has 2. Cross out d. So let's factor. It's 4 terms. So you could use grouping. I'm trying to think what colors I want to use here. If I group first terms and last terms here, pull out GCFs, x squared, x plus 2, GCF of a -1, x plus 2. I'm working up. I know, I'm sorry. X squared minus 1 times x plus 2. The x squared minus 1 is difference of squares, x plus 1, x minus 1, and you have x plus 2. Those are my factors. We are looking for x-intercepts. So I will have opposite signs for my x-intercepts. So I like a -2. Let me list them over here. So for x plus 2, I'm going to have x is -2. For -1, a +1. And for x plus 1, a -1. All those signs change. So, and they have it listed as ordered pairs just to make it even extra exciting. -2, and then there's both. What's my other one? Oh, we already crossed out A, so it is C. Yes? Oh, I didn't need to factor, did I? Because we figured out it was either C or D, right? We figured out it was C or D. I crossed out A and B from the beginning because they were decreasing. C or D, and then we crossed out D because it only had 2 solutions. With the degree of 3, you should have 3 x-intercepts, 3 solutions. I didn't have to factor. Ooh. So keep that in mind. Save yourself some time. Remember, your EOC is a timed assessment. I think this is the last one. The graph of the polynomial shows the width of a vase with respect to the distance. I love it. It's beautiful. Our answer choices, which statement is true? The width of the base is increasing or decreasing between the values of 0 or 6 to 12. So x values from 0 to 12. You got a lot going on. It's not specifically just increasing or decreasing. So let me look at 6. If I go from 6, this segment, that's increasing. Boop, boop. Increasing from 6 to 0. See that? That's all that is. Literally, if it's increasing, woo, sorry about that. Or if it was going down, decreasing. Just like slope. But we don't call it slope because slope is a special vocabulary term for lines only. So when you're talking about polynomials that are curves, if they're going up, then it's increasing. That's all. I think that was our last question. Out of that third benchmark that we did not take, all the different questions that I saw about factoring or related to polynomials, which included graphs of polynomials, factoring polynomials, division of polynomials. Did I say that already? I don't know. So there is some example questions to kind of get your brain warmed up and try those out. And I will see y'all later. Have a good one.